Open your book to page 552. Today's lesson is on the slope of a line. The slope of the line, so you already learned how to graph, right? So you did some graphing. So the slope of the line is how steep a line is. Okay, so again, the slope means the steepness of the line. And so when you have a line, you want to figure out how steep the line is, or the slope. Okay, so what you need to do, normally you want to use 2 points. So this is point 1, this is point 2. Okay? And so the point 1, the coordinate would be x1, y1. So 1, the subscript 1 means the first point. So this is the x coordinate of the first point, y coordinate of the first point. This is second point, so this would be x2, y2. Okay, so again, so 2 means second point. So this is the x coordinate of the second point, y. So this is the second point, okay, of the y coordinate. So the definition of the slope. So m is a symbol for slope. The slope is equal to y2 minus y1 over x2 minus x1. So y2 minus y1, that is the distance over here. So that's your y2 minus y1. Okay, so that's what that is. And this over here, that is your x2 minus x1. Right, again, look over here, right? So this is your y2, and this your y2, that's your y1. So to find this distance, you have to subtract. So that's where this came from. Okay, over here, same thing. You do the y. So after you do the y, you can do the x, right? So this your x2, that's your x1, right? You can see the points. So x2 minus x1 will give you this length over here. So that's it. Let's just give an example. So if this is like a 3 and this is, let's say this is 5. Okay. So in this case, the slope would be equal to 3 over 5. So again, it's this distance over this distance. Okay, the length. So it's rise. This is called a rise. It's up. Okay, so this is called a rise, and this is a run. So this is equal to rise over run. So you can just the vertical over horizontal. Okay, so that's the definition of the slope. Now, when you have, so to figure out the slope, if you have the graph, you can count the squares and you can get a slope. If you don't have the graph, if they give you the numbers, you can use a formula, or you can use the points to graph and you can count the squares. So what I mean by that is, if you go to example 2, so let's go to example 2. Example 2 says find the slope of the line passed through the point. So you're looking for the slope passing through the point -2, -4, and 6, 0. Okay. So this is again, it doesn't matter which is point 1, which is point 2. It doesn't matter. But since this comes first, I'm going to call this point 1, call this point 2. So that's your x1. This is y1, and this is your x2, and this is y2. Okay. So if you just use a formula, so m is equal to y2 minus y1 over x2 minus x1. So m equal to 0 minus -4. Now I use parentheses because when I substitute, in this case you can keep track of your negative so you don't make a mistake. Okay, so 6 minus -2. So the slope equal to 4 over 8. So slope equal to 1 over 2. Okay, so that's how you do it without graph or without looking at anything. Just use a formula. Okay, or if you have the graph, you don't even have to do all this. If you have the graph, sometimes they give you a graph. Okay, so first point is -2, -4. So this point over here. Next point is 6, 0. Okay, so this is a graph, right? And if you notice, from this point to this point, right? Notice how many are here. So it's 1, 2, 3, 4. So there are 4 over here, right? And the horizontal is from here. So 1, 2, 3, 4, 5, 6, 7, 8. And you see where the 4 and came. See the 4. Everybody see the connection, right? So again, y2 minus y1 is 2. So that's this over here. Okay, just like what we did here, right? So again, so that's where the formula came from. You just subtract the number, okay, to get the vertical, and then you subtract the x number to get the 8, right? Okay, but if you have the graph, you can just count it. So it's 4 and 8. So again, remember it's vertical over horizontal. So that's where you get the 4 over 8, right? So everybody see a connection between the graph and the equation, right? So again, so that's the y and the x. Okay. So that's what that is. So again, if you understand, the formula is very easy to remember. Okay. So again, you just subtract. So subtract the top, the y2 minus y1 to get that, x2 minus x1 to get this, and then the slope is the vertical, the y over the x, okay? So if you have the graph, you don't even have to do this. If you have the graph, you just count the squares. Okay, you got 4 over here, 8 over here, so slope is 4 over 8, so it's 1/2, right? So it all depends what it's giving. Okay? Now, if they don't give you the graph, it's probably easy, just go and just do it. You use a formula directly. But if they give you a graph, it's easy, just count the squares and just write down the form, write down your slope. Okay? And let's go to page 556. Okay, and look at this over here. So the slope, see what happens is when you read, you go from left to right. So as you go from left to right, notice it's going uphill, right? So the slope is positive when it's going uphill. When it's going downhill, when it's going down, the slope is negative. It's less than 0, so it's negative. Now, slope equal to 0 when it's flat. And when the slope is going up and down, it's undefined. So I'm going to talk a little bit more about this. Okay, so when you have a graph, right? And let's say if you have the line going like this. So in this case, the slope is equal to 0. Now, don't write down no slope. Do not use the phrase no slope because it's very confusing. Because if you use in the English sense, no slope means flat. But if you use in the mathematical sense, no slope means straight up and down. So when you say no slope, which one are you talking about? Don't know, right? So do not ever use the slope. Okay, do not ever use the no slope. Do not ever use that because it's confusing. Because you don't know which one you're talking about. Are you talking about this way or is it talking about this way? It depends on what sense you're using it, right? So what you want to do is, when it's horizontal, then m is the slope equal to 0. If the line is up and down, then m is undefined. So that's the only two that you use. So there will be no confusion. Okay? So you can only this or this. Do not use no slope. Do not ever use that. Because if you write no slope, I don't know which one you're talking about. Are you talking about this one or are you talking about this one? Okay? Because it can go either way. It depends on if you use mathematically or you just use in the plain English sense. Okay? Okay. Now, let's go to example 7. Notice example 7, you have this you have this picture over here. So notice you got two lines. Okay, so these two lines are called parallel lines. So the parallel lines will have the same slope. See over here? So this is your slope over here. So since both of them have same slope, they would be parallel. So again, parallel lines have the same slope, vice versa. Okay, same slope means parallel lines. Okay. Now over here, this one over here, these are perpendicular lines. So perpendicular lines, their slope would be negative reciprocal of each other. So again, so if the lines are parallel, so this is simple for parallel, means M1 equal to M2. Okay, so again, parallel lines will have the same slope. Okay, the perpendicular line, this is a symbol for perpendicular, it's upside down T. Okay, so then M1 equal to negative 1 over M2. So it's negative reciprocal. So for example, so let's say if this line, the slope is equal to 2/3, then the perpendicular line M2 would be negative reciprocal, so it would be negative 3 over 2. So it's negative reciprocal. See, it's negative and it's flipped over. Okay, so that's what happened with the perpendicular line. Now over here, the parallel lines, if M1 equal to 4 over 5, then if you have parallel lines, then M2 will be the same. Okay, so you can parallel lines, same slope. Perpendicular line, the slopes are negative reciprocal of each other. So you need to know those two facts. Yeah, those are very important. Okay, so let's go and do some practice.